get the screen back from current slide. I think that's where we are. All right. First, was there a question? Oh, how do you undo this? Say again? I can't hear. Menu? Ah, there we go. Thank you. All right. I was still wanting a cheeseburger, but I don't know. I never got one. All right. The couple of announcements I can remember. One of them is we have the college here has a Scholars Bowl team, and they are meeting today at 12 noon on this campus down in this building down in A261. That's as you go down the half flight of stairs, going down the lower level, second floor. When you go down that hall, the first classroom on the left, which is about halfway down the hall, is I found this the other day. I don't know why it's not on the wall. Here's where we are. Go down this long hall that way, take a right, go down that half flight of stairs. The first classroom on the left, about halfway down the hall, is 259. Then there's Mr. West's office, and then 261. Now, the reason I said Mr. West's office, he is the coach for the Scholars Bowl team. Speaking of coaches, this is Charles. No? Charles, I thought so. Okay. All right. Good deal. Now, so that's at 12 noon today. I believe that's the time. I don't have the announcement with me. Tell you what I'm going to do. It should be visible. I'm going to put it right there. All right. Now, this is even more exciting than that, if you can imagine it. Second? Amari. Amari came in. That's really exciting. Okay. Not only do we have a Scholars Bowl team, and Scholars Bowl team covers all kinds of subjects. So if you're good at anything, you're going to be contributing to the team, okay? Anything, okay? Pop culture, music, art, history, social sciences, math, sciences, any topic. If you're good at any topic, or sort of a, what do they call it? Jack of all trades but master of none. That would be fantastic too, okay? You would be good for the Scholars Bowl. But even more exciting than that, we have a math team. And the math team is meeting Friday, tomorrow, at 10 till 12. That's over on the Birmingham West Campus in the Science Building C103. Okay. Now, one other announcement, this is more personal for me. I normally have office hours, supposedly, on the Birmingham campus on Fridays from 8 to 12, but they've assigned me to go to a meeting in Tuscaloosa at Shelton State tomorrow. We'll be leaving around 7:15. I don't know when I'll be back, so it may take all day. It may take half a day. I don't know, but the odds are I won't be in the office tomorrow. Definitely not 8 o'clock, okay, and probably not anywhere 8 to 12. If we get back before 12, I'll be there from whatever that time is until 12. But the odds of that happening are pretty slim, the way they like to drag meetings on. Okay, did I say that out loud? Okay. Now, any questions on math or anything else before we get going? All right, we have already done example 4, and I don't know why it's still on example 4. Let me move on. We already did increasing, decreasing functions. Why? Here's where we are. Average rate of change. And believe it or not, we've already done this under a different name. See if you can figure out the different name. We have learned that the slope of a line, yeah, you knew this, okay, can be interpreted as a rate of change. Okay? If you think about what a slope is, someone give me the formula or the definition for a slope. Anyone remember that? Okay, let me get my pen set up. Okay, say again, M is equal to y2 minus y1 over x2 minus x1. What that means is how is y changing when x changes. That's what it's measuring. How much y is changing per unit change of x. That's what a slope is. Slope of a line is a rate of change. If this x down here were time, that would be a time rate of change. Okay? If that was gallons, that could be a capacity rate of change, as in miles per gallon. How good of gas mileage are you getting? How fast are you going? How are you accelerating? All those are rates of change. Change of one quantity compared to the other. Okay? For a nonlinear graph, this is good for a line, but for a nonlinear graph whose slope changes at every point, continuously changing, then we usually talk about an average rate of change. Okay? Because it's hard to, well, once you get into calculus, and hopefully you'll get there. And by the way, the meeting I'm going to tomorrow is my part in it is Math 112. Okay, that's what we'll be discussing in the group that I'm in. And so if you have any gripes or complaints about it, let me know today so I can let them know tomorrow. I don't know what we'll be doing about it, but that's what I'm in. Okay, for a nonlinear graph, the slope changes at every point, so the average rate of change between any 2 points is the slope of the line through those points. So here is a path of a particle, say, or something like that, okay? If you're starting here, this is called x1, and there's a value for the function, guess what that's called? You could either call it y1, or what is y always? Alpha of x is alpha of x1, okay? That's the y value, alpha of x1. Now, if you're just going to here, that would be pretty close to a linear slope. That would give you a very good estimate of the average rate of change between those 2 points. Up here, it's getting a little further off, still not bad. Up here, not bad. Over here, not a great, but it's all you got. The average rate of change from this point to this point would be the slope alpha of x2 minus alpha of x1, y2 minus y1 over x2 minus x1. Just like we saw there, nothing too new here is. Except we're doing this as an average rate of change of a continuous function. Now, we call this line here, we just determined the slope of, that's the slope of that gray line there. That's called the secant line, okay? It connects 2 points on a curve, but doesn't follow the curve necessarily, but does your best guess, okay? The average rate of change between blah, 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 blah. I think we've hit it all, right? Now, the line through those 2 points is called, as I said, the secant line, and the slope of that line is called M for slope. I don't know where M came from to represent slope, but it does. Sub SEC, that means the slope of the secant line. Okay. Now, the average rate of change from x1 to x2, as you're going from x1 to x2, the average rate of change is your y2 minus y1 over x2 minus x1, stuff you already knew, right? And this is alpha of x2, y2 is alpha of x2, y1 is alpha of x1. See, if you know that, y is equal to alpha of x, you got it. Does that look anything familiar by a different name? What's the subtraction of 2 numbers called? And the division of 2 numbers? It's a difference quotient. Just by a different name, average rate of change looks exactly like the difference quotient. Only there we said alpha of x plus delta x minus alpha of x, or alpha of x plus h. Something else, and then we just had h down here. It's exactly the same thing. And that is also the slope of the secant line. Okay. Example 6 then says find the average rate of change for this function here, alpha of x equal x cubed minus x minus 3x, okay, from the a part, x1 equal negative 2 to x2 equal negative 1. All right, so what I'm going to abbreviate like crazy, average rate of change, okay? what would that be equal to between those 2 points? Remember the formula? It was a long time ago, like 3 minutes. Last slide. What was that formula? Okay, it was alpha of x2 minus alpha of x1 over x2 minus x1. Now, what in the world is your alpha of x2? What is your x2? Okay, good. No, alpha of x2 is y. But x2, what is x2? It's right here. -1. So we could put that in down here in the denominator, -1. And what's alpha of x2? How would we get that? Alpha of x2. And that's equal to alpha of, what did you say it was? -1. Okay, I know you. It's y. Okay, got it. Okay. What is alpha of -1? How would you do that? Plug it in, and what do you get? Say again? A little louder. Help me. Yes, plug it in. There it is. Plug it in there. Instead of alpha of x, you plug in, instead of x, you plug in -1. You get -1 cubed minus 3 times -1. Excellent. Okay, and what does that give you? What's -1 cubed? -1. Okay. And -1 times -3 times -1 is plus 3. So that's equal 2. Okay. So your alpha of x2 is 2. What is your x1? x1? -2. So we're going to put minus a -2 here. Okay. And then we got to do an f of x1. That's what goes there. So there's a minus sign here. And what is f of x1? When x1 is -2. Alpha of -2 would be what? Say again? Plug it in. -2 cubed minus 3 times -2. And what would that be? -2 cubed is? Oops. -2 cubed. That's -2 times -2 would be positive 4 times another -2 would be -8. Perfect. Okay. -8. What's next? Minus 3 times -2? Plus 6. And what does that give you? -2. All right. All that for -2. Okay. So then we plug in minus a -2. Okay. Now it's just math. Good math. What is 2 minus -2? 4. Excellent. That would be 2 plus 2 is 4. Hey, high level math today. Okay. And then -1 plus 2, 1. So what's your slope? 4. 4 over 1 is 4. There it is, folks. From -2, -2, that's what we found your x1 to be, to 1, -1, 2, that's what we found the f of x1 to be, and that's a really steep positive slope, +4. Not a bad approximation for the average rate of change of that curve between those 2 points. It is the average rate of change, okay? That's what we use, the slope of that secant line right there, gray line right there. All right, that was the A part. Now, I think I probably need to erase so I have room to write. All right, okay, I'll leave it. Everybody see how we got that? People up and down the hall are saying, why is he making so much noise? on that a little bit. Not much. Any questions on this so far? See how it works. Any questions? I can see a few deers in the headlights. All right, everybody got it? Oh, still right? Okay. I know it's kind of all over the board, but I have very limited space to write. Little bitty screen. Y'all are eating this up, aren't you? Good deal. All right. Everybody finished? Still working? Okay. Can I erase this so we'll have room to do the B part? Okay. I wish I... No, it's fine. Okay. All right. The B part says this time we want the average rate of change between x1, which is 0, to x2, which is 1. Notice always our x1 is to the left of x2. Even when they're minus numbers here, alpha negative 2 is to the left of negative 1, 0 is to the left of plus 1. Always do them that way. No guarantee your f's are going to be that way, but the x's are usually that way. Not going to matter for the slope. It really won't, but we usually set them up that way. Okay? Now, where do we proceed for average rate of change for B? What's that formula? Alpha of x2 minus alpha of x1 over x2 minus x1. Okay? Now, what's your x2? Okay, x2 is 1, so I'm going to write it down here since you told me that. But we need to calculate what f of x2 is. And if x2 is 1, that's alpha of 1. And what is alpha of 1? Say again? 1. Say again? I can't hear. 2? Is that what you said? Okay. What is f of 1? I got the 1 part because when you do 1 cubed, you get 1. Minus 3. And what does that give you? Negative 2. All right. Negative 2. So there's your f of x2 is negative 2. And both of these are followed by a minus sign. What is your x1 in this one? 0. I can do that one. Okay. What's your f of x1? Which is f of 0. This is a hard one. Everybody. 0. All right. Y'all are good. Okay. So that'll be a 0. So what's your slope here? Negative 2. Negative 2 over 1 is negative 2. Does that look reasonable on this graph? Yeah, going downhill, so it's negative. Pretty steep. Not as steep as this was going up. That was a 4 here, but negative 2 going downhill. Yeah, looks pretty good. And that's not a bad estimate for the slope of that curve either. But it's just an estimate for the curve. Average rate of change between those 2 points. Does that make sense? Now, what if your first point would have been here and the second point here? then that wouldn't have been as good of estimate as what your curve is, but it's the best you got, okay? But if you did the average rate of change between here and here, it's nothing, because here it's -2, minus a -2 is 0 over 3. Well, that's still 0. Average rate of change between those 2 points, no change. Now, it did a lot of stuff in between there, but the average rate of change is nothing. So it doesn't have to represent the curve all that well. It just is between those 2 points, these 2 points, these 2 points, those 2 points, whatever 2 points you have, plus the average rate of change between those 2 points. Make sense? Good deal. All right. Let's see how they did it. First one, the average rate of change for x1 equal -2 to x2 equal -1. That would be f of x2, which is f of -1, minus f of x1, which is f of -2, divided by x2, which is -1, minus x1, which is a -2. Well, you have to go in and do the calculations here for what they are. They cheated and looked at the graph, but you actually did the calculations. You got it to be 2 minus a -2, and then the denominator is -1 plus 2, which is a +1. Okay, watch those negative signs. They're there to trick you up. That's the only purpose for negative signs, is to trip you. Okay, it's just like a stick in the road. Never mind. All right, that gave you an average rate of change of 4. Secant line has a very steep positive slope. For the B part, just the numbers change. The formula is the same. F of x2 is 1. So f of 1 minus f of x1, that's f of 0. F of 0 will always be 0. Just happened to be for this problem it was. And then x2 minus x1, that's 1 minus 0. That's pretty easy to do. Okay? Well, that would be a -2 when you plug in the 1 into your f. You got a -2 minus 0. This time f of 0 was 0, and that just gives you a slope of -2. That secant line had a negative slope going downhill pretty sharply, but not as sharp as the previous one was going up. Whoa, that went too fast, didn't it? All right. That's the average rate of change of a function. Now let's do something that's probably a bit closer to everyday life, average speed. Okay, so example 7 is not listed here, so we're going to back up and do example 7 here. The distance s, this is in feet, okay, a moving car, the distance s, a moving car is from a stoplight, okay, distance from a stoplight, okay, is given by the function s of t is equal to 20t to the 3/2 power. What a strange formula, where t is time in seconds. Okay, distance in feet is 20t to the 3/2 power. Time out a moment here. What in the world do we mean by fractional exponent? T to the 3/2 power. What does that mean? Okay, if that were t cubed, what would that mean? T times t times t. Okay, we know what that does. What if that's t to the 1/2? Does anyone know what that means? Not quite. The other was raising to a power. This is, in other words, cubing it, the 3 did. The square in the denominator tells you to take a, not raising to a power, but doing a square root. Exactly. This is the index of the square root. So this would be t cubed, but take the square root of that. Or take the square root of t and then cube that answer. Either way, you can do it either way. So that's what t to the 3/2 means. The t is either cube first and then take the square root of the answer, or take the square root of t first and then cube the answer. Works both ways. Okay. Back to business. where t is in seconds. Find the average speed of the car from t1 equals 0 to t2 equal 4 seconds. Okay? So let's do that. How in the world could we find the average speed of car? Guess what we would use? Second? I'm sorry. Yeah, the formula for it. Oh, same formula. Is that what you said? Okay, one little difference. It's not an F anymore. It's an S. So it's S of, and it's not an X anymore. S of T2. Second. Minus S of T1 over T2 minus T1. Y'all are good. Okay, what in the world? Get out of there. That's not you. Okay. All right, what is S? Okay, T2 is 4 seconds. So what is S of 4? S of 4. What would that be? 20 times 4 to the 3 has power. Okay, sorry I wrote over that. In fact, I'm going to get rid of this so it won't be confusing. We already know time is in seconds. Okay. Now, what do we do first here? Take the square root? No, I like that way of thinking, okay? You do the exponent before you do the multiplication. Remember, please, yeah, right, okay. Now, which exponent do you do? I always like to take the root first, because if you cube this, you're going to make a big number, and then you got to take the square root of a big number, okay? Whereas you take the square root first, you're going to get a smaller number, and then you're cubing a smaller number. I'm lazy, okay? So I like to do it the easy way. And evidently somebody else is lazy in here too. Okay, so what would that be? 20 times, and what was the square root of 4? 2 cubed, and what would that be? Still do exponents first. 20 times 8, and 20 times 8 is 160. Excellent. Okay, and that'd be 160 feet. So S of T2, which is 4, would be 160 feet. Now this has units. Most of the time I don't carry the units around, but this time it will be helpful. Minus, now we have to do S of T1. And what's your T1? Second? 0, okay? Anyone want to make a guess about what 0 to the 3 has power is? 0, and 20 times 0 is? 0, excellent. Okay, we got that one done. All right, divided by, and then what's your T2? 4 minus, okay, now we've lucked out and had 2 that the function was 0 at 0. They're not always. Let me warn you of that. What's 160 divided, and this is in seconds, by the way. 4 seconds. So this will be 160 divided by 4 is 40 what? Feet per second. The units are your friends here. And guess what? The average speed, feet per second, an excellent unit for speed. Distance per time, miles per hour, kilometers per hour, feet per second. Yes, that is a good, see, units are your friends. They tell you when you've made a really bad error if the units don't make any sense. Okay? Now, that's the A part. The B part says between T1 is equal to 4 seconds and T2 is equal to 9 seconds, I believe. They were very kind to you, weren't they? They gave you T's that were all perfect squares. You expect that on a test? Never mind. Okay. What do you think? S of T2. That's S of 9. What would that be? $20, you're right, times 9 to the 3 has power. And that would be, what do you do first? I like the square root first. That'd be 20 times, what's the square root of 9? 3 cubed is, what's 3 cubed? Ooh. 27. So that'd be 20 times 27. Any of you do that in your head? Please say yes. 540. Excellent. 540 feet. Okay, remember that S is in feet. We want to go on and do, hey, do we need to do S of 4? No, we did it last time. Remember, we already got it on the board somewhere here, don't we? There it is, right there. What was it? 160 feet, okay. So I think we can almost set up our average speed of the car. I couldn't read my writing there. That would be S of T2, which is 540 feet, minus, this time your T1 is not 0, minus 160 feet, divided by 9 minus 4. 9 seconds minus 4 seconds. And that's going to be 540 minus 160. Pretty close to 380. Is that right? 380. 380 feet divided by 5 seconds. 5 will go into 38 7 times with 3 left over. That's 76. Is that right? 76 what units? Feet per second. Excellent. Okay, 76 feet per second. So for the first 4 seconds, it was going at 40 feet per second, average rate of speed, and for the next 5 seconds, it had increased to 76 feet per second. Better slow down soon or you'll see the blue lights flashing, okay, and it won't be Kmart. Never mind, okay. All right. So, to see how the book did, 40 feet per second, 76 feet per second. Okay. Make sense? All right, good deal. All right, any questions? Average rate of change. Very practical application sometimes. Okay, so let's move on to even and odd functions. What in the world could that mean? Okay, something's going to be even and odd, we hope anyway. You have studied different types of symmetry of a graph. In the terminology of functions, a function is said to be even when its graph is symmetric with respect to the y-axis. So if the y-axis is here and the function does the same thing on this side that it does on that side, or vice versa, that's said to be an even function. Symmetric about the y-axis. Said to be odd when the graph is symmetric with respect to the origin. So if the function does this on this side of the origin, it does this on that side of the origin. It does exactly the opposite to what it does on the other side. That's symmetric with respect to the origin. Now, they've left out the biggest classification. Anyone want to make a guess what that would be? It's a trick question. Second? Okay. Negative time, is that what you said? No, okay, I can't hear. It's a neither. Neither even or odd. Functions don't have to be even or odd. They can be neither. In fact, most functions you'll run into, my guess, will be neithers. Okay? Now, once you get into trig functions, they're just about all even or odd. So there will be exceptions for that. But a lot of functions will be a neither. Now, here is a symmetry test that yield the following test. That seems like it's really redundant, isn't it? For even and odd functions. Okay, so here's what we do. Test for even and odd functions. Okay? A function y is equal to f of x. Oh, I may not and get up. Okay, y is equal to f of x is even when for any x in the domain of f of minus x is exactly the same as f of x. Now that kind of makes sense, doesn't it? If you have a function here and it's symmetric about the y-axis, if you go to the left over here, f of minus x, and find the value, when you go to the right, that same x, you better get the same value because it's the same on either side. So f of minus x is equal to f of x. Now for it to be odd, is from every x in the domain, f of minus x is exactly opposite of what f of x is. Well, that makes sense too. If it's symmetric about the origin and your f of x is up here, f of minus x is better be down here. Exactly the opposite of it. All right, that's what we just said, isn't it? So what's our test? The test is if you have a function y is equal to f of x, and we don't know whether it's even or odd, all we do is do f of minus x. Just plug in a minus x rather than the x, figure out what it is. If it comes out exactly the same as f of x, it's an even function. If it comes out exactly opposite of f of x, it's an odd function. If it comes out something different, neither the same or neither one of them are the same or opposite, it's a neither function. The biggest classification most of the time. Okay? So, let's do one. Here's a function. G of x is equal to x cubed minus x, and I hate that they tell you what the answer is before you do it. Here's what you do. You do g of minus x. And what does that give you? Tell me how you do it. Instead of x, you put in second, negative x. That'd be negative x cubed minus a negative x. All right? Well, what's negative x cubed? Negative x cubed. Okay, it sounds like I'm saying the same thing, doesn't it? But that's not, okay? A negative x in parentheses cubed is negative x times negative x times negative x. Well, negative x times negative x is positive x squared, and then multiply it by another negative x, and you get a minus x cubed. So this is a negative x in parentheses cubed. This is a minus x cubed, okay? And then what do you get when you do minus a minus x? Second, plus x, okay? Now you look at that result. How does this compare to that? Exactly the opposite. The minus x cubed is the opposite of that, and plus x is the opposite of that. Exactly the opposite, so that means it's what? Odd function. You got it. Okay, that means it's odd. They went on and did the math here, just like we did, got the same result, and that shows that's exactly the opposite of g of x. So g of x is this. You pull out a minus sign, and you got the exact, pull out this minus sign, and change the sign of both of those, you got exactly minus g of x, which is the test for an odd function. Right? Now, here's another. H of x equal x squared plus 1. What's the test? H of negative x. And when you plug in a negative x, what do you get? Negative x squared plus 1. Yeah, that doesn't change. There's no x in it. And what's negative x squared? That's x squared, right? Negative x times negative x is positive x squared. Plus 1, and what do you have there? Exactly h of x. And if the h of minus x is exactly the same as x of x, what do you have? Even function, exactly. Okay? Well, this is where you substitute, you get that. That's exactly h of x. That's the test for an even function. Okay. Here are the graphs of those, and you see that indeed this is an odd function. Over here on this one, it's going down first and then up. Here it's going up first and then down as you go. So it's exactly the opposite of this. You plug in a minus x here, you get the opposite of y here. Okay? Whereas this function, the little parabola here, whatever is happening on the right is the same thing's happening on the left. Exactly the same. Now, the following that I'm about to say works only for polynomial functions. I don't know if you remember what polynomial functions are, do you? There's functions with multiple terms. This is 2 terms, that's 2 terms. They could have 15 terms, they could have 3 terms, they could have 1 term. That doesn't much with multiple. Polynomial is how many terms it has. And a term means all the exponents are only whole numbers. Okay. Whole numbers. No negatives, no fractions, no decimals. 3, 1, 2. Ooh, what's the exponent of that one? 0. Exactly. Y'all are good. Okay. Now, I want you to notice something. Now, what I'm about to say, works only for polynomial functions. These are polynomial functions. What are the exponents here? And what do you notice about those 2 numbers? Odd. They're both odd numbers. Isn't that funny? And how about this one? And what are those? Even numbers. Okay. So for polynomial functions, the dead giveaway. Look at your exponents. They're all whole numbers, and they either got to be even or odd. And what if this had been an x squared here? What would that have been? Odd? Even? Neither. That would have been one of those neither functions. Okay? Or if this would have been x cubed minus x plus 1. Neither, because that would have been, that plus 1 would have been a 0 exponent. That would have been a neither. Okay? It would have been odd, odd, even. Okay? Y'all are good. This would have been an x squared plus x plus 1. Neither. Y'all are excellent. Good. Okay. Any questions on that? I'm sorry, I just made it so much easier. Sorry about that. I should have kept it hard. Okay. That is and by the way, there are checkpoints after every example. Please do those as soon as you can after class. And that does finish 1.5. Let's go to vocabulary in 1.5. And number 1, this is top of page 56. The blank, blank, blank is used to determine whether a graph represents a function of x. The graph represents a function of x. The blank, blank, blank. Vertical line test. Excellent. Okay. Number 2. The blank of a function y is equal f of x are the values of x for which f of x equal 0. The blank of a function y is equal f of x are the values of x for which f of x equals 0. The zeros of a function. How did you guess that? Okay. The zeros of a function. Very good. All right. Number 3. The function f is blank on an interval when, for any x1 and x2 on the interval, as long as x1 is less than x2, that implies that f of x1 is greater than f of x2. That function is, say again? No, those would be the same. If it's greater, it's decreasing. Absolutely. If every one of them, that's the case. Okay. Number 4. A function value f of a is a relative blank of f when there exists on the interval from x1 to x2 containing a somewhere in that interval such that x1 less than x2 implies that f of a is always greater than or equal to any of the f of x's in there. The function value f of a is a relative what? What? Did I hear? Huh? Okay, it's multiple choice for me. Okay, let me see. Which is that? Yes, it's either maximum or minimum. The key is f of a is greater than any of the other f of x's. That would be a maximum. Of course it would. Excellent. Number 5. The blank, 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 blank between any 2 points, x1 f of x1 and x2 f of x2, is the slope of the line between those 2 points, average rate of change, and that line is called the blank line. Secant line. Y'all are good. You remembered it from earlier today. Okay. And a function f is blank when, for every x in the domain of f, f of minus x is minus f of x. Odd. That's an odd function. Excellent. Y'all are good. Homework exercises here. Either 9 or 7. They're both at, either 7 or 9. They're both at Calc Chat. 9 will be at Calc View. Either 11 or 13. They're both at Calc Chat. 11 will be at Calc View. Any of the odds, 15 to 25, they're all at Calc Chat. 25 will be at Calc View. Any of the odds, 27 to 31, they're all at Calc Chat. Any of the odds, 33 to 39, they're all at Calc Chat. 35 is at Calc View. Any of the odds, 41 to 47, they're all at Calc Chat. Any of the odds, 49 to 53, they're all at Calc Chat. 51 is at Calc View. Any of the odds, 55 to 57, they're all at Calc Chat. 57 is at Calc View. Either 61 or 63, they're both at Calc Chat. 61 is at Calc View. And then and those are the ones we did today. Any of the odds, well, no, do 65, it should be at Calc Chat. And then do either 67 or 69, they should both be at Calc Chat. And then others we did today, any of the odds 71 to 75, they're both at all at Calc Chat. 71's at Calc View. Any of the odds 77 to 81, they're all at Calc Chat. 83's at Calc Chat. 85's at Calc Chat. 87's the error analysis. I really don't care for them as much, but it's good to think through. Just understand what they told you is wrong, and you figure out why it's wrong. Okay, 89 should be at Calc Chat. There's a couple true false, 91 and 93. They should be at Calc Chat. 95 should be at Calc Chat. 97 is a writing exercise. If you see anything there that would lend you for your paper topic, that would be fine. 99 goes back to even, odd, or neither. That should be at Calc Chat as well. Any questions? Second? Was it page number or what? Okay. Oh, you got it? Okay. Second? Yeah, I'm going to throw it away. Okay. Throw it away for nothing. Okay. Now, let's move on to 1.6. All right. Sort of a weird title for this section, but it's pretty easy. And by the way, this is pretty straightforward. I wish I had already made up I've got the quiz made up, I just don't have them copied. I'd go on and give you the quiz so you could have an extra weekend to work on it. If any of you want to hang around right after class, I'll run down and make copies, and you can have an extra weekend to work on the quiz, because there's not that much in 1.6 that's on the quiz. We're still in Chapter 1, Functions and their Graphs. We're now in well, let me get this slideshow set up. We're now at 1.6, a library of parent functions. Okay. We'll identify and graph linear and squaring functions. We'll identify and graph cubic, square root, and reciprocal functions. We'll identify and graph step and other piecewise defined functions, and we'll recognize graphs of your parent functions. You will do that. Okay. So let's start with linear and squaring functions. Okay? One of the goals of this text is to enable you, the student, to recognize the basic shapes of the graphs of different types of functions. For instance, you know that the graph of a linear function is, guess what? Second? Did I hear an answer? Okay, that's a way to express it, what would that graph look like? A straight line. That's why they call it a linear function. This graph is a line, straight line. Okay? And the slope, by the way, as we were just saying, is A, and the y-intercept is 0b. Now notice that a y-intercept is always a point. A point is designated by an ordered pair. The first element of that ordered pair for y-intercept is 0, because the y-axis, anything on the y-axis, its first coordinate is 0. Because x is 0 on the y-axis. Okay? And then whatever your b turns out to be, that's your y-intercept. How many y-intercepts can a function have? One and only one. It may have none, but it can't have more than one. Okay, good deal. The graph of a linear function has the following characteristics. What do you reckon the domain of a linear function would be? All real numbers. Okay? There's one line that's not true for. What line is that? A vertical line only has one input value, whatever its thing is. Is that a function? No! So a linear function is always going to have domain set of all real numbers. How about the range? Usually all real numbers except for one case. Second?
Horizontal.
No. Horizontal line. What's the range of that horizontal line? Whatever that value is right there. That's the only value it ever has. Now, is that a function? Yes. Any y only intersects at y. Okay, trick question. Okay, so that is a function because the vertical line test passes every time. But its range is only a single number. If you have any slope at all, positive or negative, the range is all real numbers. What's true about a horizontal line? What's the slope? 0. Okay, so if the slope is 0, it doesn't have a range. So whenever m is not 0, the range of the function is also the set of all real numbers. These are linear functions. The graph, okay, now this is a bit bizarre. The graph of an x-intercept is this, whereas the y-intercept, we know what that is. If the function is, they haven't written it down, y is equal to mx plus b, then we know the y-intercept is 0b. Okay? Now, they sort of threw in here this x-intercept. But we could have calculated that, couldn't we? Because if what, oops, let me get my pen set up. Okay, yeah. All right. If it's y is equal to mx plus b, what is true about the x-intercept of a function? Any x-intercept, what's going to be true about it? Any point is an ordered pair, xy. What's true about the x-intercept? The x-intercept. Second. You may be saying it right, I just can't hear. The x-intercept, what's one of its coordinates? Always. Second. Which one? Y is 0, because it's on the x-axis. It's not up or down. Y is 0. So this is going to be some number 0. Y is 0. Well, that gives it away, doesn't it? If y is 0, you can put 0 is equal to mx plus b. Now, the x value is going to be what goes in the blank there. So let's solve for x. What's the first thing we would do? Subtract b from both sides. I'm going to write it up here. 0 is equal to mx plus b. Subtract b from both sides. Oops. This will be minus b is equal to mx. Wanting to solve for x, divide by m. And the m's go away here. So what is your m? What's your x? What is your x? Minus b over m. There you have it. That's where they got that. Minus b over m, because when you set y is equal to 0, your x has to be minus b over m. Do I ever stop and think and figure that out? No, I just look and see. I just plug in a 0 for y and calculate what it is. Okay? It's what? Oh, how could it be? Let me finish this graph. Okay, this slide. The graph is always a linear function is either one of three things. Increasing, when is it increasing? M is positive. Or it's decreasing when M is negative. Or it's constant when M is 0. You got it. Perfect. Okay. We'll pick up next time with example 1. Okay? So no new homework exercises here. Do any of you want to hang around for me to go make out? Okay. Make the copies. Several? Or, okay. Does anyone who wants to hang around have another class that you have to get to? Okay. And let me see if I have any spares. I may have. I have one spare. If anyone needs to run, you need to run? Okay. Do you need graph paper? You don't? Okay. We're going to need graph paper. Yeah, good. Excellent. Okay. I'll go make copies for the rest of you. Goodness, this is ragged. There are 38 in here. I gave one away, so I need 37. Okay. I'm going to end this.